So okay, so we are gonna talk about transformations in this unit. And specifically, we're going to talk about quadratic transformations today. Okay, so first thing we're going to do is talk about what happens when we graph the most basic of quadratic transformation or quadratic functions. Okay, so if this was my equation, how would I find the vertex of this equation? What was that formula?
Negative b over 2a.
Correct. So specifically, x equals negative b over 2a. So what is my b value? If it's not there,
0.
It's 0. Thank you. So technically it'd be opposite of 0 divided by 2a, which a is
1.
1. Sorry, I'm getting private comment notifications coming through on my phone, and I'm like, whoop. Oh, geez. Just gonna turn that off. Not gonna respond to all the comments. Again, if you are commenting on the enrollment, that's fine. I just can't handle it right now. All right, so it's 1. But what happens when we have, technically you can't have opposite of 0, but either way, 0 divided by anything is 0 divided by anything is 0. Yes. Okay. Now, if I put 0 in to my equation, I will also get a value of 0. So therefore, my vertex for this most basic function would be 0, 0, aka the origin. Okay. What about my y-intercept? What is the equation for my y-intercept? How do I find the y-intercept?
Zero C, but there's no C, so it's 0, 0.
Correct. So it's 0C, but since there's no 0, we would have 0, 0. Hopefully you're seeing a pattern here so far. What about that x-intercept? How do we solve for x-intercepts? How do we find our x-intercepts?
You set equal to 0 and then solve.
Correct. So we set it equal to 0. You're not going to have to do any factoring, quadratic formula, or completing the square on this problem because x squared equals 0. That would mean that x equals 0. There's nothing fancy about that one. So again, you have 0, 0. Okay. Now, we are going to do like real graphs in this unit, but for this first one, I'm just going to draw like a makeshift graph here on this so we can get a visual. Okay, now if the vertex is 0, 0, the y-intercept is 0, 0, and the x-intercept is 0, 0, we really don't have much else to go about. So therefore, we're going to have to think about those other points and symmetrical points. Okay, now gonna be a little easier. It's not really much work that's gonna be shown. What would be the value when x equals 1? If I substitute it into my graph.
1.
Correct. If I substitute 1, 1 squared is 1. Okay. What would be the symmetrical point to that? About the origin, what would be the symmetrical point to 1, 1?
-1, 1.
Negative 1, 1. Okay, let's do one more because we only have 3 points. So what would be our point at 2? What would be our y value at x equals 2? So if you put 2 into the equation, 2 squared, you would get emails. You would get 4. 2 squared is 4. So therefore, the symmetrical point would be
-2, 4.
-2. So thank you. All right, so we have our minimum of 5 points. Obviously, it's not graph paper, but do the best you can. Oop, I always one side, I always do that. Okay, so this is what we refer to as the parent function. This is the original equation of all quadratics. It's the most basic form of a quadratic. It's at 0, 0 for almost for everything, y-intercept, x-intercept, and the vertex. So for quadratics, this is what we would refer to as the parent function. So essentially any equation that includes x squared, whether it's plus 2x or minus 10, all of those are essentially like children of this equation. So this is the original, it's the parent, it's the head of the family. Everything else from that is transformations from it. So let me write that down, what I just said. So the graph of any quadratic function is a transformation of the parent function. Okay. Now, I don't think I've used this word yet, but does anyone know what we call the shape of a quadratic? I don't think I've said it, so maybe someone knows it, but anyone have an idea of what the shape of the graph of a quadratic is called? Okay. It is called a parabola, spelled P-A-R-A-B-O-L-A. Parabola. A lot of students like to call it a parabola, but it's a parabola. So a parabola is the graph of a quadratic. Okay, kind of like when we name a linear graph a line. These names just don't match up as nicely as linear and line. So quadratic is a parabola. Okay, so since we talked about that everything is a transformation from this, now we need to discuss what do those transformations actually look like and how do we know that they're a transformation? well, it's actually a nice equation that you'll use to figure that out. So we have standard form, which we've talked about before, we've used before, used a lot in the last unit, which is y equals ax squared plus bx plus c, okay, which is great. But we have another form that will be more helpful for us in reference to, oh, where did the 4 come from in the other point? We squared, so 2, substitute 2 into the equation. 2 squared is 4. So that's how we got 2, 4. That makes sense. Where we got 4 from. Yes, no, the person that asked that question. Does that make sense? Thank you. Okay, so we have our standard form, which is great, but it doesn't actually help us look at transformations. So the other form that you'll be learning about is called vertex form. Okay. Vertex form looks like a little different, but it looks like y equals a times the quantity, aka parenthesis, x minus h quantity squared plus k. So you're probably like, why do we have new variables in there? Well, we just got to change it up a little bit. Okay, couple things. A can still not be 0. Remember, that was a rule from standard form. If a is 0, then you won't have an x squared. So a can't be 0. And then this h and k that comes into play is your vertex. Hence why we call it vertex form. Okay, much like when we did point slope or slope intercept, the name represented what you found. So point slope, you saw a point and a slope. Okay, slope intercept, you saw the slope and the intercept. Vertex form, you can see your vertex. Now, I'm gonna have to change my page. I'm just giving you a second. Okay, like I said, vertex form is gonna help us find those transformations, which I'm gonna write down next. But I'm giving everyone a second to look at that. Oh, good, a lot more people filled out that link. I appreciate it. Oh, and you're welcome for the student that was asking about how we got number 4 or how we got 4. So it would be the points that we put in the vertex form. So it would be the points we would put in the vertex form. Are you referring to the vertex itself? I'm not sure what you mean by your question. So we're going to be working with vertex form more in this next unit, almost exclusively, but we'll show how standard and vertex are related. Yes, like we'll find the vertex, the origin. Yes, so you'll be able to find the vertex straight from the vertex form without having to do opposite b over 2a. So the h coordinate would be the x coordinate in the vertex and k would be the y coordinate, correct? Yes. Correct. Good job. Good job for foreseeing that. Okay, so I just said it out loud a bit ago, but I'm going to write it down for those that need that visual versus the audio. Okay, again, vertex form allows us to easily see the transformation of the parabola. Okay, so I'm going to write it down again, just because I don't see mine. And then we're going to start talking about what all these letters mean in reference to transformations. Now, remember, transformations, back when you learned the very basics of transformations, were just reflection, shifting, dilation. Okay, we all remember those types of things. So we're going to do the same thing, but a little bit fancier. Okay, so H. H means, or is, the horizontal translation. Okay, horizontal translation. What would that mean in reference to a graph if I was moving something horizontally? What directions are those?
The X.
The X values, so we're moving it left and right. Good. Okay, so H is our horizontal translation, our X values, moving left and right. Then we have our K, which is the vertical translation. So vertical would be in reference to
Up or down.
up or down, yep. And if you need to write out the full word, if you're not going to know what LR and UD means later, feel free to write left, right, up, down, whole thing. Okay. Then we have A. Okay. A, sorry. A is the vertical stretch or compression. A is the vertical stretch or compression. Okay, what do you think happens when you stretch or compress a graph, or anything for that matter? What's another way? What do you think happens? So if I had this headband, for example, if I vertically stretch it, means it's going to elongate, right? If it's like this and I stretch it, it elongates. If I compress it, it flattens. So we have vertical stretch and compression. So stretch and compress. Now, because there's two different things that could be happening, we have to indicate that based on what A is equal. So if A is greater than 1, it's a vertical stretch. Okay, which makes sense. If I multiply something by 2, it means it's twice as long, twice as big. Okay. On the other side, if A is between 0 and 1, so 0.1, 1/2, 1/4, 2/3, okay, any of those types of numbers, that would be vertical compression. Okay, again, if you multiply something by 1/2, you multiply by something 2/3, it's going to get smaller. It's going to be more compressed. Okay. Now, A is actually a double agent. It does two different things. It talks about vertical stretch and compression. It also talks about reflection. So A is also a reflection over the x-axis. Now, specifically the x-axis. So reflect over the x-axis. There is reflection over the y-axis. We just don't get into that until junior year. Okay. So A is also a reflection over the x-axis. How do we know it is? But only when A is negative. Okay, so it is only a reflection over the x-axis when A is negative. Okay, so those are our 4 transformations. Horizontal translation, meaning left and right. Vertical translation, which means up and down. A, double agent, which means vertical stretch or compression. Of course, my kid picks the noisy toy. And then we also have A, which could be a reflection. I'm gonna shut the door. So what we're going to do in the next examples is we're going to describe the transformation. So I'm going to give an equation, and based on what H, K, and A are, we'll be able to describe what happens to the graph. Without even graphing it, we'll be able to describe the transformations. So number 1 is not really a trick question. It is more or less a verification that you understand what's going on. So, is there any transformations that happen with y equals x squared? Are there any transformations for y equals x squared?
No, because it's the parent equation.
Correct. So there is none, there's no. Okay, this is the parent. So if it's a parent function, that means it's the original, there's nothing. Sorry, I started to put a T in it. Parent function. If it's a parent, there's no changes. All right, first real one. Y equals x squared plus 2. Okay. What do we think the plus 2 is referring to?
Probably the y-intercept.
Okay, so that's a good point, but I'm meaning in reference to transformations. In reference to transformations, is it going left, right, up, down, stretch, compression, reflection? That's what we're trying to figure out here. What transformations are happening? Where do you think the plus 2? Any ideas? Okay, so plus 2 in this problem is in referencing up to. Now, how do I know the difference between up and down, left and right? Because, right, H and K, I'm either adding or subtracting them. But if it is an H value, it will specifically look like this. It will specifically have parentheses around it and then a square. So anytime you just see plus or minus a number on the outside of x squared, that's always in reference to up and down. So therefore, this would be a vertical translation up 2 units, which is the full correct answer. So if you just put up 2, that would be incorrect. It is a vertical translation up 2 units. Okay, number 3. Now that we've done number 2, this should be a little easier. Y equals x squared minus 5. What's that going to be?
Translation down 2 units.
It is going to be down 3. Yeah, just make sure you say the whole thing there. I'm not sure if I missed it at the beginning. Vertical translation down 5 units. Okay. Now you'll see a little bit clearer for number 4, even more so. Obviously, the more we do, the clearer things become. Y equals the quantity of x minus 3 squared. Y equals x minus 3 quantity squared. Okay, so in general, this is when we're going left and right. Okay, so we know it is a horizontal translation. Okay, but this one is a little tricky. Okay, someone guessed in the chat left 3 units. So it's actually right 3 units. And the reason being is the original equation minus right here? So the original equation is minus. However, when you pull out your h value, you're pulling it out in reference that this is still minus. So if the original equation is minus, when you pull out your h value, that sign doesn't actually come with it because the original was minus. So when you pull out the 3, it's just the 3 itself. So therefore, a horizontal translation of right 3 units. Now, on the flip side, and this one typically makes it a little easier to figure out why it's that way. If I had x plus 1, okay. Remember, the original equation is minus. So in reality, this equation originally should have been y equals x minus a -1 quantity squared. Because when we do a double negative, it becomes positive. But again, because the original equation is minus, that's why this happens. And that's why it's so confusing. Because normally we don't have minuses in equations, right? Almost every time we do something, it is positive. But if you think back to when we did point slope form, I'm just pulling a random piece of paper out, we would have y minus y1, this equation. What would happen if you had a negative number, right? You would do y minus a -2, which would make it plus. But that doesn't mean that number wasn't originally -2. So that's kind of the situation here. Because the original equation is minus, when you pull out that value, it actually ends up being the opposite of what you visually think it is. So therefore, because the original equation is minus, that means this would have been a -1. So that's where we would have a horizontal translation to the left. Now, I know that was a very long-winded explanation, and most of you are probably just going to be like, okay, just do the opposite of what you see. But it is important that you guys know why we do the things we do, okay? So again, the main point is that because the original equation is minus, when you pull out that number, it actually ends up being the opposite of what you visually see. So in point forever, if you have x minus a number, it's actually a positive, so therefore you're going right. If you have x plus a number within the quantity, it's actually a negative number, meaning you go left. So essentially, you kind of have to trick your mind to think of it looking at it that way. Okay. Questions or concerns for horizontal translation? That is a harder one to conceptually understand. Okay, let's try number 6 then. Y equals 3x squared. Okay, looking at the information provided to you, y equals 3x squared. Anyone want to take a guess? Maybe someone that hasn't guessed anything yet? What do we think would happen if it's 3x squared?
Is it a vertical stretch?
It is a vertical stretch. Good job. Oh, sorry. I was trying to scroll on the chat and sorry. Okay, 3x squared. So remember, A is a vertical stretch or compression. A is in front of X. Okay, so I appreciate the guess. It doesn't look exactly like the equation because it doesn't have as much going on, but it is in front of the X. So it's a great guess, great context clues. So it is a vertical stretch by a factor of 3. Number 7, y equals 1/2 x squared. Okay. So again, now that we have 6 under our control, what would 7 then be?
A vertical compression.
Correct. It's all about going back to the letters that we've defined. So vertical compression by a factor of 1/2. And again, if you don't write exactly like these statements on the homework, that would be wrong. So if you just said compression of 1/2, which is normally what students will go for, doesn't count fully, I guess I should say. Okay. Lots of different ways to transform. Okay, number 8, last normal one, I should say. Y equals negative x squared. Okay, this one should be a pretty easy one to guess. When a is negative, that means we have a
Reflection over the x-axis.
correct, and that's exactly what you write. This one doesn't have a very fancy way of saying it, but of course, it is important that you do say over the x-axis, because although there is a reflection over the y-axis, and although you won't really learn it till your junior year within the IB courses, you can't just say reflection, okay? It is reflection over the x-axis. Okay, so in the next couple examples, what I'm going to do is I'm going to combine the transformations, which is a little bit normal, a little bit more normal, I should say. So you could have up to how many transformations on one equation? How many transformations could you have on one equation? I'll give you a hint. It's how many we've talked about. How many transformations did we talk about? How many? It wasn't 3. There are 3 letters, but it wasn't 3 transformations. I appreciate the guess. It wasn't 5. Again, but I appreciate the guess. How many did we talk about? 4. We talked about 4. Left, right, up, down, stretch, compression, reflection. 4. So you can have up to 4 transformations on one equation. All right, number 9. Y equals quantity x minus 2 squared plus 1. What is one of the transformations?
A horizontal translation, right 2 units.
Good. Okay, so one of them is horizontal translation, right 2 units. And the other one is
A vertical translation up 1.
correct. Plus unit. Vertical translation up 1 unit. Okay, anything else? Is there anything else going on in this equation? It's just a yes, no question. Nope, that is correct. Yeah, a couple people put no in the chat just now. No, that is all we have. There's nothing left. Our A is 1, so 1 doesn't mean stretch, 1 doesn't mean compression, and 1 doesn't mean a reflection either. If A is 1, it's just normal. Okay, let's try number 10. Okay, y equals 1/3 times x plus 5 quantity squared minus 4. What about this one? Well, y equals 1/3 times x plus 5 quantity squared minus 4.
Vertical compression by a factor of 1/3.
Good, good job. Okay, good. That's one of them. Thank you, Harper. Horizontal translation left 5 units. Good. Thank you. Thank you, Christina.
And a vertical translation down 4 units.
Thank you, Bennett. Thank you. And the vertical translation. Oh, forgot the N. Translation down 4 units. All right. questions so far of how we're combining these? Okay, let's try the next one then. Y equals -5 times the quantity x plus 9 quantity squared plus 2.
Reflection over the x-axis.
There's a reflection over the x-axis, good. That's one of them.
Horizontal translation left 9 units.
Let's see. I'm gonna call on someone new if no one else volunteers that's new. I do appreciate those that have been
Vertical
helping.
translation up 2 units.
Oh, I didn't even finish writing everything I wrote here. Okay, let's get someone brand new that hasn't answered any questions. Or I will give a request to someone to. See. Anyone want to guess on the last one? Hopefully a new person. We'll see if someone will step up and try it. I really don't like cold calling, especially over the internet. It's a little harder.
There's a vertical stretch by a factor of 5.
Good job. Thank you, Danielle. Okay, and that one is actually the hardest one on this one for some students because some students think because it's a -5 that it's actually a compression. And some of you are like, well, why would that be? The reason being is that some students forget that it has to be between 0 and 1 for a vertical compression. And some students just think automatically, if it's negative, it's less than 1, so it's compression. But specifically speaking, compression is only between 0 and 1. So because A is a double agent, it could be a vertical stretch and a reflection. It could be a compression and a reflection. It can be both things. Okay, but specifically that A value is either greater than 1 or between 0 and 1. So I'm not sure that could have been why someone may not have suggested that one, because that's actually typically the hardest one for some students to know right away. But great job, Danielle. Okay, let's try the last one. Y equals -3x squared minus 4.
Reflection over the x-axis.
Good. Actually, someone said it and wrote it at the same time. Good job, guys. Both Carla and Harper, I think that was. Good. What else do we have?
Vertical translation down 4 units.
It happened again. Someone said and typed at the exact same time, the same one. Vertical translation. Down 4 units, good. Last one.
Would it be a vertical stretch by a factor of 3?
Correct, good job. Okay, really good job with all of that. Okay, so the next thing we have to do is graphing. There's only 20 minutes left of class, so I don't really want to start graphing right now just because it's a little bit of a harder topic to kind of get understand. So I don't want to start it here at the very end. So for that reason, we're going to stop here. For your homework assignment, I'm going to provide the homework assignment. I'm going to verify with Ms. Bergman if she wants us to split it. But you will just be doing the first part of it. So obviously 6-1 is a long thing. I'm going to confirm and see if she wants me to break it in half or break it apart. Just so that we're doing the same thing. But it'll just be this part, but once we go over it, we'll have to do graphing. This lesson might take 3 days at this rate, just because it is a very big unit or very big lesson, but we will see what happens. So Friday, we will do graphing. We will do live notes. Please bring graph paper. And I will confirm what your assignment is in Google Classroom. So have a great day. If you have additional questions in regards to enrollment, let me know, and I will spend the rest of class time trying to get back to everyone on their comments on Google Classroom. So have a great day.
Thank you, Miss Shannon. Bye.
Thank you. Oh, sorry, Dariana, I will fix that.